Hi, this is Don with Ridge Engineering. In this tutorial, I'm going to give you an introduction to our new GPS2LT3 software, which is the companion software to the new PC Travel version 3 that we've recently released. GPS2LT3 is used to collect the data in the field. I'm going to show you how that works, how the software works, and just give you a good overview of how you collect data in the field. GPS2LT3 uses GPS receivers as the way to collect the data, and this apparently is what a GPS receiver looks like, at least according to Google. Now, when you collect the data, you're going to be out in the field in your car or van or truck or whatever, and you're going to be using a GPS receiver. And let me show you what we're talking about. So there are many different types of GPS receivers out there, but the ones that we like the best for this application are little GPS receivers that have a little magnetic mount, and they go on the roof of the car, and then the cable goes through the passenger side window typically and plugs into a USB port on your computer. Now, these GPS receivers have gotten really inexpensive in the last few years, and now you can get these for around $30. And on our PC Travel support site, there's a links page where you can find the Amazon page where we buy our GPS receivers when we get them, and you can get your own for, like I said, around $30. We also recommend that people use a little remote control, and this is what it looks like. This one happens to be made by Kensington, but there are a few others. It has a receiver that plugs into the USB port of your laptop, and then it has 4 buttons, but we only use one of the buttons, this bottom rectangular button with the little white rectangle on it. And the way that works, and I'll show you in more detail a little bit later on, but the basic idea is that instead of having to lean over and hit keys on the keyboard, which can be a little tricky while you're driving, you just have this little remote control in your right hand typically, and when you start a run, you press that button, and then you just drive through the entire route, keeping up with the traffic, not doing anything interesting or exciting. And at the end of the run, at the end of the course, you press that same button, which stops the run in the software. And then you typically go around the block or make a U-turn and come back through the same intersection from the opposite direction. And again, you start the run by pressing the button, drive, don't do anything else. At the end of the run, you press the button. So your data collection consists of starting the software and getting it working, and then during the driving, you press the button on the remote once at the start of the run, and you don't have to be particularly fussy about where you do that, just somewhere within 5 to 10 seconds of the beginning of the course. Drive, don't do anything at all, and when you get to the end of the course, go through the last intersection or whatever marks the end of the course, and press that same button again. So pretty simple. Now, in GPS2LT3, we're introducing a new feature where you can use voice recognition to control the software, and I'll show you how that works a little bit more later on. And there's going to be a separate tutorial just on voice recognition, so you get a more complete idea of how that works. But a lot of people want to collect what are called reasons for delay as they're driving, and that can be a little tricky to do with only one person in the car. It's easy with 2 people in the car, but most people don't want to have 2 people in the car if they can help it. So we've been playing with this voice recognition idea where the driver is wearing a headset like you use with Skype or other types of programs like that, and to start a run you just say run start, and to enter a reason for delay you'll enter something like delay 1 or delay 2, and at the end of the run you enter run, stop. And the software will interpret that, know what to do, and go on from there. And the advantage of that is you can do reasons for delay without needing another person in the car. If you don't want to do reasons for delay, then really the remote control is fine, because one person driving in the car, it's very simple to use. But if you want to use reasons for delay, then the voice recognition, I think, will be a very good option for you. All right, so let's get into the software. I'm not going to show you how to install the software. Half the time you have to use your IT people to help you anyway. And it's just a standard Windows installer, so there's not too much to it. But when you do that, you'll end up with an icon on your screen that says GPS2LT, a shortcut. And when you double click on that icon, you get this first screen. There's only 2 screens in the software, so it's not too complicated. The first screen sets everything up, and the second screen is used to actually collect the data. So I'll go through what's on this screen and show you what you have to do. Now, the first thing you have to do is you have to enter a study name. Now, typically that's going to be the name of the arterial or the main street that you're driving on, or a highway if you're doing a highway study. And I'm just going to call it test for now. And you want this name to be relatively short, around 10 or 12 characters max. And the software actually will prevent you from trying to put in long names. And the reason for this short name is later on in the software, in PC Travel, the software will generate run names out of this study name and add a -R001, 2, 3 to all the runs that it creates. And that adds a few characters. And then in the software, on the reports, you want the run name to look reasonable on your reports. And things get a little tight on the reports in some places. So if the run names are too long, they just don't look good and it gets crowded. And there's no real reason for that. So in the study name, keep the name as short as you can. You don't have to have the date in the name at all, because the date is all over the place in the software. You don't have to have the direction, because the direction will typically change from one run to the next, and there's a way of automatically having that happen. So normally just put in the street name and keep that street name to less than 10 or 12 characters. If you have to abbreviate it, that's fine. Just abbreviate it so that it's fairly obvious what the name is. The software then will store the study in the folder that's shown here, and the default is in the library section of your computer, and the installer creates a folder called GPS2LT3 and then a data files folder underneath that in the documents section. And that's the default where these will go. And there's rarely any reason to change that in the field. So this is where the data is going to go. There's already one study called Sample 1 that is in here. And then if normally you will do the study, copy these files to your main computer in your office, either using connecting through a network or using a USB drive or something like that. And then once the file has been copied over to the main computer, you don't need it on the laptop anymore, so you can just delete it in Windows and keep this folder relatively clean. So give it a name, make it relatively short, 10 to 12 characters max, and everything will be fine. Then you have to select some options. One is the GPS receiver, and 90% of the time you'll just use the generic USB. Now what that means is that if your receiver plugs into a USB port on your laptop, that means it's a generic USB type, and The other type that we support at the moment is Bluetooth, and there probably will be a tutorial on how to use Bluetooth GPS receivers. Often they're used as data loggers, and a data logger has its own memory, so you don't need but some do, and so you can use a GPS receiver with Bluetooth and not have to have a cable going to the laptop. That doesn't work if the GPS receiver is on the roof, but if you have it up in the dash, which isn't great, but it's okay, that's an option. But almost all of you will use the generic USB, which will be the default. Then there's a COM port that has to be assigned. Again, in this tutorial, I'm not going to show how to install USB GPS receivers. We may add a small tutorial at some point on how to do that. There is a section of the PC Travel Quick Start Manual that does talk about how to install the GPS driver and how to find out what the COM port number is. But in general, you'll use whatever came with the GPS receiver. You'll usually come with a CD and install the driver that came with that, and then once it's installed, the computer will assign a COM port number, a number from 1 to 32, and that is the virtual COM port that the GPS receiver is assigned to, and it's what the software is looking for. The software assumes the GPS receiver will look like a serial input device, and in order to connect to the GPS receiver, it needs to know what COM port it's been assigned. So when you plug in the GPS receiver and you go over and click on this down arrow, you may only see 1 or 2 numbers. If you have a laptop, a lot of times there'll be a number 1, maybe a 1 and 2, and then another number. The GPS COM port is almost always going to be that other number, because on laptops, serial ports 1 and 2 are often assigned, pre-assigned to other things like the mouse that is on the laptop, or other things. So if you see 2 numbers, almost always the second number is going to be the COM port. But the proper way to do it is to use Device Manager on your Windows computer and find what the number has been assigned. And you can find the directions on how to do that on the Quick Start Manual that you can download from the Downloads page of the support site. The GPS receiver also has an associated baud rate, and for most of the generic USB receivers that we use, that's fixed at 4800. But there are other GPS receivers that run at different rates, slower and some faster. So you may have to look at the documentation that came with your GPS receiver to see what the baud rate is. It's normally not adjustable. You can't say, oh, I want it to run faster, so I'm going to set this to 9600. It doesn't work that way. The GPS receiver will have a fixed baud rate set in it somehow, and that is the number that you need. Generally, if you don't know, use 4800 and then try it, and if it doesn't work, it's pretty obvious. All right. Then there's something called the GPS read mode that is probably going to go away pretty soon, but we've been testing 3 different ways of reading GPS receivers in software like this that we write, and we just didn't know which of the 3 would end up being the best. And we did a lot of testing, but you can never do as much testing as you want, and they all had their pluses and minuses, and in general they all worked well, but some worked just a tiny bit better than others in some cases. A couple of times we had a little bit of trouble installing or getting one of the modes to work. So we decided initially we're going to have all 3 available to you, and if you have trouble with one, start with one, and if you have problems, and it's not subtle, normally. It's you just won't connect to your receiver and you won't get any data. So if that happens, which is unlikely, but if it happens, try the number 2 mode, and that'll, if one doesn't work, the other probably will. And within a few months, we expect to know which of these is likely to be the best, and then we'll just get rid of this and it'll be fixed in that mode, and you won't have the choice. But for the moment, if you're reading this or you're listening to this, then and you see the GPS read mode option on your screen, that's what it's about. So there's 3 options. Start with 1. Probably that'll work just fine and you'll never have to think about it again. But if you have issues, you might try 2 or 3. And if you have issues, let us know so that we can figure out what's going on and what seems to be working and what doesn't seem to be working. All right, there are some other options. You can enable that little remote control I showed you at the very beginning of this. So if you're going to be using that little remote control, you want to check this box. You can enable speech recognition, and I'm not going to go into any details on that in this tutorial. There'll be a separate one where I go through it in great detail. You can also input the run direction at the start of each run, and I'll show you what that does in the next screen. You could also enable the ability to enter reasons for delay. A reason for delay is like a stoplight or a stop sign or congestion, and the software actually has always allowed people to enter reasons for delay, but it's been clumsy to use, so because in general you need 2 people in the car to do it safely. Now that we're playing with speech recognition, it makes the idea of entering reasons for delay more viable, and so now we're going to be adding more software in PC Travel to do things with the reasons for delay and show them on separate reports and on the graphs and things like that. In general, we expect if you want to use reasons for delay, you probably want to try to use speech recognition to avoid having 2 people in the car. At the moment, it seems to be working very well. We tried it years ago with Windows XP and maybe the beginning of Windows 7, I'm not sure. Didn't work very reliably. But since Windows 8 and Windows 10, it seems to be very good. And even going back to a Windows 7 computer, the new speech recognition software is pretty good. All right, so, and then if you are not in the continental United States and you want metric view for speeds, you check this box. And then all speeds will be shown in kilometers per hour, and which will make more sense. This is primarily for our Canadian users. We have a lot of people in Canada that use the software. And of course, they've been smart enough to go to the metric system a long time ago. And probably the US will never do it. So you select whatever options you want. I'm just going to select none at the moment. And when everything is ready, you click OK. Now, the software will start reading the GPS receiver, and it will put up the information on the left-hand side of the screen. The first thing to look at is the time. The time should be the local time, and the seconds should be incrementing nice and smoothly. Sometimes if the GPS receiver is having a hard time, you'll see that the dates, the times are not incrementing smoothly. It may go 55 and then stick there for 4 seconds and all of a sudden jump to 60 or 00, and that means that there's something wrong with the interface with the GPS receiver. So make sure that the seconds are incrementing nice and smoothly like they are here. Typically, you're going to be running this screen from a parked car. Initially, you generally don't want to be running, setting up the software while the car is moving. So the car is going to be in a parking lot or pulled off to the side of the road. So the speed's going to be essentially 0, and that's what you would expect. The latitude and longitude should be reasonable numbers, and you may not know the exact latitude and longitude of where you are, but it should be a positive number for latitude and a negative number for longitude if you're in the US. And typically the heading will be -1 to start, because the heading doesn't really work if the speed is below 5 miles an hour. So we have in the software that if the speed is below 5 miles an hour, it just puts -1 for the heading, and the software later on knows what to do with that. And then there's a couple of, well, 3 other parameters, and these are all GPS receiver parameters that you almost never will look at. But if you're having a little bit of trouble, the fix tells you whether or not you're getting the additional differential correction signal from the satellites. So this should be a 1 or a 2, and since I'm inside, it's laboring a little bit, so it says it's a 0. But outside you'll get a 1 or a 2. Either will work okay, but 2 is better than 1, and 1 is better than 0. The number of satellites is how many satellites can the GPS receiver see at the sky at this particular moment. And it needs 4 satellites in order to calculate the latitude and longitude and the speed. And if it has more than 4, it picks the 4 strongest signals from what's available. So the more satellites, the better. 7 is pretty typical. You'll often see 8, 9, or 10 as well. And the HDOP is a fancy term for what's called the horizontal dilution of precision, which is a number that what it really means is, given the 4 satellites that I have here that I'm using, how well spread out in the sky are they? Because if all these satellites are relatively in the same direction in the sky, then the trigonometry that's used to calculate the latitude and longitude and the speed doesn't work as well as if the satellites are scattered in the 4 corners of the sky, that's spread out. And so this number gives you an indication of how spread out the satellites are that you're using for your solution to find these numbers. And again, if something seems to be working but this number is really low for some reason, like 0.2 or 0.3, that could indicate that the GPS receiver is not working quite right. It's not getting all the satellites for whatever reason. But to be honest, you'll almost never look at these numbers, and they almost will never mean much. So you'll see the study name that you put into the previous screen up there, and the run number, and the node number, although we don't recommend that people mark nodes in the field anymore. It's best done on the map, but some people still like to do it, so we let them do it if they want to. But in general, you won't worry about nodes because you won't be collecting the nodes in the field. So typically you'll set this up on the side of the road in the car. Everything is looking good right now. The background is red or light red, which means that it's not collecting data at the moment. And now you drive towards the first intersection of interest, and when you get within a few seconds, anywhere from 10 to 1 second from the intersection, depending on how precise you like to be, you either click on the R button on the laptop, or better, you press the button on the remote control, and that starts a run. And so when the run starts, the background turns light green, which means the software is collecting data and storing it in the data file. And it shows the information that it's receiving in this grid that is then scrolling down the screen. And normally you don't pay any attention to this, but if occasionally you might want, if there's a problem, you might want to look at this and get a clue for what might be going on. Normally you just drive and you don't look at the screen at all. You just drive, and out of the corner of your eye, you normally check to make sure that the background color of the screen is green. So that's pretty easy to do without taking your eyes off the road. If something happens to the GPS receiver, if the connector pops out of the USB port or something like that, the background will start blinking and turning red, trying to get your attention that there's something wrong. But normally it will just stay green. You'll drive through the entire course, and when you get to through the end of the course, once you've driven through the last intersection, you'll press the button or hit the R button again on the laptop, and that will stop the run. And it no longer, now it's not collecting data anymore. It's paused. It hasn't stopped the software, but it's just paused the data collection, and the background is light red. And so now you typically will make a U-turn or go around the block or do whatever you have to do, and then you'll drive through the intersection going in the opposite direction, press the start run button just before you get to the first intersection, and repeat the process. The background turns green. You drive, don't do anything, go through the last intersection, hit the stop run button, and you just keep that going. And when you've gone through, you've done as many runs as you can, try to do a couple of more, because you can't do too many runs with PC travel, with travel time and delay studies in general. And the biggest problem that we have with people is that they don't collect enough runs, and therefore there's not enough statistical variation in their data to give you results that are meaningful and accurate. You almost always need 4, 5, or 6 runs in each direction for the data to be accurate. So try to keep that in mind when you're planning your data collection. When you're all done, the background is red, you can pull over to the side of the road or pull into a parking lot, and then hit the End Study button. So this brings us back to the first screen. Now normally we would exit the program and then bring the laptop back to the office and transfer the file that we collected in the field to the desktop computer where you run PC Travel. You could either transfer the file with your network or with a USB drive, but somehow you would get that file onto your desktop computer and then run PC Travel to process it. Now there's a couple of options that we can look at. So I'm going to check the input run direction at start of each run and enable enter reasons for delay, and then go back to the data collection screen. And we're reading the GPS data, but now there's a couple of new little boxes on the bottom of the screen. One is the run direction, and if I want to, I can check this one of these options, say northbound. Now what that does is it embeds the northbound in the data that's collected by the software, so that later when it's processed into runs in PC Travel, that run will have the study name and then a dash and then the direction, the NB or South SB or whatever, and then the R001. So by looking at the run name, you can see the direction of travel. Now you have to do this at the beginning of every run, and typically what you would do is if you're driving by yourself, collecting the data by yourself, you don't want to have to lean over and find this little checkbox. So at the end of every run, you would pull over to the side of the road, end the run, and then set the run direction for the next run. Usually it would be the opposite direction, but not always. Sometimes people have courses where they do circles, or so it's not always exactly the opposite, so we don't have it automatically toggle. But normally you would just set this, okay, I've just driven northbound, I've ended that run, I'm going to set the next run to southbound. And then you drive, and you do that for every run. That's a little bit inconvenient to have to go over to the side, but a lot of people like this feature. And then a lot of people, to be honest, don't, because it's kind of annoying to have to remember every time to set the direction, and then if you forget and leave it at the same value as the last run, then the names get a little bit messed up. But if you're meticulous and you like this idea, then it's available to you. Now, if you start playing with the speech recognition software, this is done automatically, because you can say, instead of normally starting a run with run start, you would say run start eastbound or run start southbound. And the software would recognize the run and the start and the direction and adjust everything accordingly. So this is another option for the speech recognition that might make it useful for people. Even if you're not using reasons for delay, if you like the run direction option, then the speech recognition might be something you want to try and see how it works for you. All right, the other is reasons for delay. Now, reasons for delay are numbers that correspond to a list that you've made up and that you can edit in PC Travel. And they're numbers from 1 to 16. And we have a standard set that we start with, but you can also edit them yourself. So 1 might be a stoplight, 2 might be a stop sign, 3 might be pedestrian congestion, 4 might be vehicle congestion, 5 might be really bad weather, 6 might be an accident, whatever you want to come up with. And the idea is that anytime as you're driving, if you have to slow down more than you would like to for that particular road, then there's some delay. And what is the reason for that delay? A lot of people would like to be able to keep track of that stuff. So stop signs and stoplights, well, that's just a part of the driving, that's okay. But if you have to slow down a lot because there's 500 school kids crossing the street, that might affect that run and make it seem a little bit odd. And if there's no way of marking or saying there were pedestrian delays at this point, then it might not be obvious why the numbers of that run were a little bit different. So a lot of people like the idea of reasons for delay, and you can do it with the speech recognition, or you can just do it in the car. Now, the way you do it is as you're driving. Let's start this run. So now we're collecting the data, and say I want to put in delay number 1. I just type in the 1, and what it does is for that second, that record, that 1 second, it puts the number 1, and then it goes back to blank. And then I can put in a number 2. But without speech recognition, you have to type this on the keyboard. And so that's a little bit awkward to do if you're driving. And so most people, if they wanted to do that, would use another passenger. So somebody sitting in the passenger seat would have the laptop on their lap, and they would handle all the reasons for delay as they're driving along. So this is the run direction and the reason for delay, two other options that you can use with the software. Okay, so that's a pretty good introduction to the software. Hopefully you'll have no problems using it. If you do have any questions or problems, you can go to the Contact Us page on the support site and fill out the form and put in your question, or you can just call the toll-free number that's shown on that page. Good luck.